have a big machine here today. So what are we learning?
Oh, today we're going to learn about modified atmosphere packaging, or like you might heard before, MAP. As you can guess, because of the name MAP, basically what you are doing is modifying the atmosphere in the package by replacing it with a desired gas mixture.
So it sounded like to me you have to remove the air from the packaging first and then put in the desired gas mixture, correct?
Not necessarily. Everything depends on the equipment that you are using. Some machines will vacuum the air and then replace it with the gas mixture that you want. Other machines will just flush the gas mixture and just replace the gas in the headspace. In addition, it is important that you evaluate or analyze the headspace in the packaging, and for that, you need a headspace analyzer.
So why do people want to modify the atmosphere inside of food packaging?
Well, the main purpose to use modified atmosphere is to extend the shelf life of a food product. When you use MAP, you basically are reducing the oxygen in the packaging, and that slows down oxidation and microbial growth in the product.
So it sounded like MAP is a type of reduced oxygen packaging, ROP. Is that correct?
Usually it is, because usually we're going to remove the oxygen from the package, and the packaging material that we are using doesn't allow the transmission of the oxygen from inside to outside the package or vice versa.
So if there's no transmission of the air between inside the packaging with the outside of the environment, it sounded like the gas composition inside the package would never change during shelf life, correct?
Not necessarily. Actually, the gas combination in the package might change over time, especially with the microbial growth. For example, you can have a packaging that has 40% nitrogen, 30% carbon dioxide, and 30% oxygen. That will be considered a high oxygen packaging. But if you have aerobic bacteria that starts growing through the shelf life, they will consume all that oxygen, and since there is no oxygen transmission, then your oxygen in the package will go to zero and it will turn into a reduced oxygen packaging.
So what types of MAP are there?
There are different types. For example, you can use just a 2-gas combination, or you can use a 3-gas combination. Usually nitrogen is used as a gas carrier, and this can be combined with carbon dioxide or with carbon dioxide and oxygen. For example, for retail, the gas combinations that you can use are carbonated soft drinks, 100% carbon dioxide. For dry foods, you can use 100% nitrogen or 30% carbon dioxide and 70% oxygen. For hard cheese, 100% carbon dioxide. Bakery, 50% carbon dioxide and 50% nitrogen. For red meats, raw, cooked or cured, 30% carbon dioxide and 70% nitrogen. And for fresh fruits and vegetables, 5% oxygen, 5% carbon dioxide, and 90% nitrogen.
So it sounded like different types of product have different types of gas combination. So the gas composition is the only factor we need to worry about when we do MAP?
Yes, the main thing that you need to know is what is your target mixture that you want to achieve with your product, but it's not that simple. You need to understand how the gas mixture properties work and how your equipment work. So the physics of the gas are going to be different from one to another. Then the machine will also have different gas flush time, the pressure of the gas, the seal time. So all that is going to depend on the gas mixture that you are using. While MAP can have a greater impact extending the shelf life of a food product compared to vacuum packaging, it does require more training, better understanding of the equipment, and more experience.
Wow, it sounded complicated. Thank you for the lesson. And I think I will stick with the vacuum packing for now. And in the future, if I want to move to MAP, I will make sure that I consult with an expert like you.